is the one which makes you feel, oh my gosh, what is happening to us? Let us say something to the children like this. That is
Absolutely.
how I came this morning to agree to talk to you about, and hopefully it'll make sense.
It'll definitely settle. Definitely, I think we should get going. I mean, of course, my friends wanted to give a formal introduction to you, so I'm not going to rip
Okay,
them
let's
of the
start.
opportunity. But I wanted to talk just for 30 seconds, if it's okay for everyone else, because I just wanted to give a perspective of how I came to know of you and things like that. And of course, then one of my colleagues will give a formal introduction, and that's going to be okay. So, Professor Vinjamuri, I met with him in a temple. To be honest with you, I of course, now there's a good opportunity for us to collaborate, which we just started. So we met in a temple where Professor Vinjamuri is an integral part of. He helps with some decision making and things like that. And then we ended up exchanging pleasantries, and that's when he asked me what I was doing and things like that. Initially, he was thinking that I was an IT person, which because 90% of the people that go there are IT people. So I said, well, I'm not. So, and then I told him, I thought he was 90%. And I told him, well, sir, I lead a small research group. He said, oh, really? I'm a scientist myself. Wow, wait a minute. So he said, okay, once you're done, why don't we go and just talk? And we said, yeah, sure, sir, let's go. So we went aside, we had some lunch, and then we spoke about a few things. And then we struck a chord because we were thinking, wait, there's something that we could definitely do, which is climate change, alternate fuels and things like that. And then I ended up knowing that he served for such a long time with the U.S. Department of Transportation. I was just thinking, well, sir, you definitely need to come and talk to my friends here. And then he kindly consented. And then we rented a small place in a library. We went and sat, discussed for an hour and a half. But we discussed a few opportunities to work with, and that's when I realized that he was actually a classmate of Abdul Kalam in India. And then he taught Professor Abdul Kalam differential equations. I mean, so he was talking about the story. I mean, if I talk about all that, and I think I'll rob him of the entire hour and a half. So I'm going to stop here. I thought this was quite interesting, and of course there are other bits and pieces I could add. But I thought this was great, and his contributions to a patent which he's just got is amazing. He's 86. And he just received a US patent. It was absolutely phenomenal. I was in total awe. That was fantastic, really. So I thought, I requested him. I told him, I requested him and I was asking him, looking for an opportunity for him to just come and talk to all of us, to provide, passes the energy and the enthusiasm that he brings in is amazing. So with that note, thank you again for accepting to give us a talk. So really nice. It's we're pleased to host you here. So I don't know who's going to just give a formal introduction. Is it so? Who's doing it? Go, Arvindo. Okay, yes, go ahead. Mate, go ahead. Soham, please introduce yourself first and then provide an introduction so we'll know who it is. Yep.
Namaste, my name is Soham. I'm from Maharashtra, India. Welcome everyone to the most awaited lecture of greenhouse gases issues and solutions from transportation sector. In this lecture, we will learn adapting methane and hydrogen strategies to replace fossil fuels and mitigate the impacts of climate change. I'm very delighted to introduce to you Gopala Vinjamuri. Let me give his overview about his education. He has done BSc in mathematics. He has pursued diploma in aeronautics from Madras Institute of Technology in 1960. He has completed his master's in applied mechanics in Lehigh University of United States. He has also given his Nobel service of 45 years in industry and government. He retired in 2005 from United States Department of Transportation as principal staff engineer, and then he has also started his own Vinjamuri Solution Innovation Company. from 2013, and he is a CEO of that company right now. He has 3 patents and 23 publications in his name. He has also been awarded with a prestigious UN ICAO fellowship at NASA Langley Research Center, and Innovation Board of India has awarded him the Presidential Award for the year 1968. On behalf of YAP Indian cohort of 2022, I welcome you with open heart and cheerful mind. We consider this our privilege to see you here as a part of YAP cohort. Thank you so much for accepting this invitation. We really look forward to take this anubhav.
Thank you, Soham. So over to you, sir, please.
I start here? Okay.
Yes, please. Yes, please, sir. Yeah.
Okay. Again, I'm so glad I met Professor Subramaniam, and he was into forest at the time when he talked. He was into forest fires in Western Ghats, and I am into methane emissions. And I saw a connection between us. I thought I got make use of him to do some write-up on the subject matter. How do we connect forest fires to the methane emissions? So then he was busy man. So I just gave up on him now. So now the best part of it is today, thank you, Professor Subramanian, giving me this opportunity. Okay, we appreciate it. And I hope I'll make a sense. And let us start. Again, you want me to control the slides? You want to do them?
I can do that, sir. If it's okay with you, I can do it.
I can control also. If
here it's difficult, sir, because I'm
okay.
Yeah.
Okay. If I went too long in a slide, and because we have a lot of slides, let me know. I'll cut off quickly. Okay.
Absolutely.
We'll start. Again, like I said to the people in the front before the seminar. The 65% of the audience today that Zoom in would be biologists, and the rest are all physics students and mathematics students and probably others who are tuning in today. I was scared first and then said, how can biology and me connect? But then I found out, after all, I was a biologist for the last 20 years trying to address the environmental issues. And biologists are the closest to the environment, from the cells in the body to the great humanity, the human health as we live in the society. So that's wonderful news. So with that background, go to the next slide then. And I tried to learn about biology. That's what I said. And then I found out the biologists are the closest to the environment. They develop respect towards the nature and the protecting the nature. That's why I thought, I got a connection with 65% of the audience today, and I got excited. So I started working on it. So let's go back to the topic of the today. Next slide, please. What is today? Today is the climate change. I don't know how many of you came across climate change. Climate change is something that we are all doing in addition to what nature was doing before before the Industrial Revolution, and that climate change is manifesting itself into a variety of increasing in frequency and intensity of the natural disasters. We've been using crude oil and natural gas for decades and decades and decades for the energy. And we produced electricity, and we produced petrol, diesel to run the cars and the commercial vehicles, airplanes, you name it. We've been using it. As part of it is, as we are burning these fuels for energy, we are polluting the atmosphere, not knowingly or knowingly. And even the electricity, the people who are using chemical plants, the industry is using it. So the impact of that is what I said is the increasing frequency of natural disasters, like We have storms, unbelievably strong storms. We have droughts, forest fires, like Professor Subramanian will be interested in. We have erupting volcanoes, much more intensity and longer time these days, and also decreasing societal health in urban areas like New Delhi, Bombay, or Madras, whatever it is. And of course, there will be some, because of this, there will be imbalance of the natural resources across the world, and there will be potentially international conflicts for resources. There was an issue about a few years ago. I was talking to somebody. There will be a lot of conflicts related to the availability of water, drinking water, right? And so that's what it is. Though the solution is, so we say, in addition to the natural phenomena of some kind of pollutants going up into the atmosphere, like a methane from swamps. In China, swamps put out 30% of the methane, natural gas, into atmosphere. And we have swamps, and we have waste products, we have cow dung. All of these things are all putting methane, which is natural gas, into the atmosphere naturally. But in addition to that, is the use of the automobiles, energy for other purposes. We are putting out much more intense emissions of pollutants. So if crude oil and natural gas are one of the fossil fuels that are we're using extensively, the solution would be to simply replace them with something that is not polluting. Now, maybe, preferably, we want to have natural resources like wind, solar, bioecology, which is again biomass, burning waste and things like that. Okay. Now, then what we are trying to do is, that is the 1980s. In fact, it started in early 80s. And then in America, then we started looking at natural gas as this is the solution. So, and then by the middle of 1995, we said natural gas is also giving us some pollutants. So hydrogen is the one. So now the alternate fuel philosophy emerged out in USA, and now it is progressing quite rapid. I think we are a little bit short of the cusp for an exponential growth. Again, the time constant for all these kind of issues would be a generation, 25 years. And so we are somewhere near that. In a generation, we will be replacing oil and natural gas as the energy sources, and probably we'll be using maybe still some kind of natural gas, but we'll be probably using hydrogen as a fuel of the future. Okay, with that is a solution. Now we're going to talk about the issue, what the problem itself. Where is that problem is coming from? Only in relation to transporting of the energy resources, which is basically crude oil and natural gas. And methane emissions, again, go ahead, next one, go ahead. Next slide. This is what's happening to the world, and the entire world, many places we are seeing the drought. Next one, please. Go ahead quickly. See, you have seen enormous rain recently in India, unbelievable. It poured into the cities and city water, and people claimed, and then they got trying to excuse, oh, we don't have a drainage. No, but the amount of water that came out of the sky is unbelievably centuries before. We never had that kind of pouring rains, and these are all part of the climate change. Forest fires in USA, it is increasing in numbers and intensity enormously year after year, in spite of the sophisticated society and technology that they have. That means some kind of climate change is overpowering us in terms of natural disasters, and we have to start working on it. It will take a long time. Next slide, please. So here is another one, which is the tornadoes. The tornadoes used to be about maybe in a season about 10 or something like that in the Midwest. Today, it is the whole. We see numbers of them are enormous. And they come back as if it's an army, one after the other, one after the other. Never happened before. But this is again, we think it is the climate change. Climate change is simply, next please. And what is this climate change? See, originally, the sun's rays, when they come onto the earth, part of it is reflected back, the infrared radiation or radiation power that is reflected, a little bit of it is absorbed. And that little bit of observation is become a necessary evil, because that is one to keep us all warm on earth, on the earth's surface, in the water, the warm. That's what is happening historically. That is a natural phenomena. But when we are putting out a lot of gases like carbon dioxide, natural gas, which is methane, nitrous oxide, other pollutants, they form a cloud around the atmosphere. And when the infrared radio on the right side, you can see on the infrared, I can use a color. Oh, I can see them. See here. So some of the radiation is observing, some of the radiation want to go back, but it can't go back. So that is what is causing the temperature of the earth increasing. Even on a mean level, even as a little bit as 2 degrees centigrade, 4 degrees centigrade, it is enormously disastrous to us. And this is what is called the greenhouse, greenhouse gases effect. Next slide, please. So what are the greenhouse gases? This is carbon dioxide. Essentially 65% of it, we are putting it because we are burning a lot of coal for energy. The oils and all, they have hydrocarbons, have carbon. When you burn, you have a carbon dioxide out. And we have nitrous oxide out of that. And we have we will talk more about methane. We have a natural gas going into the atmosphere that we are putting out in the large quantities is another problem. That's a greenhouse. And again, from the forestry fires that we are taking, a lot of forest fires also cause the carbon dioxide out of it. And then also the removing the trees will increase the temperature of the earth. So these are the gases that we're looking at it. Today, it's not, for me, of course, I'm not knowledgeable of all of this, but I want to say something about methane. 16% of the greenhouse gas is methane, and who is putting that out into the atmosphere? And what is a solution? Is there a solution? And we have to find a solution if the solution is not pragmatic. Okay, next slide, please. Next slide. Okay, here is what's going to happen. This is an industry that is putting out lots of carbon dioxide into, because they're all, these cars are not even, next slide please. This car is not even, they're not even moving, they're stagnant. The engine's running, okay? And from the exhaust, you can see what's happening, you see. In USA today, there are 300 million cars that are registered. 300, I think the entire world is close to 1 billion cars that are using either petrol or diesel, and they're putting out lots and lots of carbon dioxide. This is the problem. Another problem, major problem is, in fact, the use of oils and natural gas for transportation. And then this is again because we're using petrol and diesel. Suppose we can have, we remove all these cars are running with hydrogen or low polluting natural gas only, then we would have had some impact on the climate change. Okay, impact on the emission of carbon dioxide, that is a greenhouse gas measure, and so we would have had some kind of impact on it. So the entire world is now considering how best we can replace all these cars to run, all this kind of population to run on either natural gas or hydrogen. Today, as of today, natural gas is the lowest hanging fruit for us, in spite of the fact that even with it has certain pollutants, like it does emit nitrous oxide and particulate matter into the atmosphere, but at a low level. Much lower level than either petrol, the gasoline, or the diesel. Next slide, please. So again, these are the chemicals that we see in the major constituents in the greenhouse gas is nitrogen. Oxygen will be there, carbon monoxide, which is poisonous. These are all the gases that we see. We also have many of the natural gases have the sulfides, and then we have nitrous oxide, organic acids come out of that. You won't believe it. These oils, and they have a tremendous amount of chemicals that we don't want in the atmosphere. Next slide, please. Energy is an important issue for us. We need energy, electric power, or some kind of energy to run chemical plants. Our products and all have to be made here, but they also put out, now they're using either coal-powered electricity or natural gas or diesel. And next one, please. This is the big issue for energy itself. I'll tell you how big it is. If you look at it, the global greenhouse gas emission by sector, if you look at it, you can see almost 73% of the energy is coming out of the industry, transport, and in the way of buildings, in the way of buildings in the sense where we use this again is global, so it may not, the buildings may not apply to the Indian atmosphere, because in USA there's huge buildings like what we are here today, with a lot of natural gas as the piping into the cooking and all. Most of it is either in transport or in use. There's a lot of natural gas is being put out into the atmosphere locally. Okay, so that is it. We also have greenhouse gas coming out of agriculture, and there's a variety of crop burning is one of them, which is in India, it is a problem, I understand. They're trying to take the crop and make that electricity out of that, okay, bioelectricity, biomass. And so you can see the variety of reasons why the greenhouse gas emissions are occurring in the world. And so there's no way that I could even think of addressing the whole of this picture, but I just thought, let me see, even though the transport is only 16.2%, and that is a problem that is now facing, and we should find a pragmatic solution to that one. And that will probably creep up into much higher level into the industry to run the plants, the power plants with the hydrogen, fuel cell power, and things like that. And so let's go back. Next slide, please. So we are thinking of, at the moment, as of recent 2014, but it may be different right now. But China is putting out 30%, but China's greenhouse gas is because they burn lots of coal for power, much more than any other country. They are not getting out of it, okay? And United States is because of their use of power. It's amazing how much power they will use in terms of automobiles and in terms of energy. The production of natural gas itself is a greenhouse gas, I will show you later, is a potential. And transport is a big issue there. And of course, India at that time was only 7%. Today is 2022, so these numbers may be changing it. But even if it is smaller in relation to the other United States and China and Europe, the future, the way we are going with the building highways, 4-lane highways, and along with that, influx of foreign cars coming in, and everybody is buying a car for 5 lakhs or 7 lakhs of rupees. If we continue to use oil and natural gas for this, we will have a problem of pollution and pollution, as well as related problems with the health and the rest of it. So this 7% in 2014 could be little more today, in both in quantity or as a percentage of the global issue. Okay, and we want to be conscious about that as we go into future, immediate future, not even long-term future, immediate and short-term future. We got to think about what are we doing in a hurry in trying to bring in so many cars and company manufacturers. Why is that our population is seeking more and more cars to move about? If they can move about in in a faster way, like Western countries, it's okay. But in India, we can do that, but still we are producing a lot of cars, and we have to. Ultimately, it will have an equilibrium, and we will be looking at more and more cars and transport. And with the highways built up, then the commercial transportation will increase. And if we don't do anything, we'll be using a lot of diesel oil for that, okay, diesel for the commercial vehicles, and that will be a problem in future. Okay, we have to think about it right now and see in about a generation, which is 25 years, we can turn the corner and say less and less pollution, less and less use of oils. And then in about 50 years, we would be mostly we'll be running with a zero emission power with the hydrogen or any other future resource like that we can find out. Next slide, please. Here is what the methane emissions, I will come back to natural gas. All these blue lines are the methane that is seeping out of the industrial complex, including transport. Some of the areas are very strong. And here is what I was talking to Professor Subramaniam. When we took a look at the western coast of India, we are already using natural gas wells. We are producing natural gas, methane, and we are trying to liquefy it and store it. All of this process, and then transporting from there to end user, all of this process will have some kind of leakage of natural gas into atmosphere. So if you look at even the western coast alone, as the way we are doing it, there will be some concentration of natural gas in that hovering just above the coastal areas. And if the way my vision was may be wrong, to connect forest fires to increasing forest fires, if it is, to the availability of methane in that region. Yeah, that is why I got into him. I said, let us see if it is possible to understand it. Is there any connection with the progression of the natural gas industry along the west coast, including the LNG terminals and all, and the increasing frequency of the forest fires? That's all. That's R&D topic, but we may not do anything. We may not find anything, but that is a topic by itself. Okay, next slide, please. So the entire world is concerned. So there's a United Nations, under United Nations, there's 196 countries met and said, how do we go about this problem of pollution, the greenhouse gases and increasing temperature, the Earth's temperature. Next slide, please. So the Paris Agreement, which is called Paris Climate Accord in 2015, said it was an international treaty. It is not simply something. People have to come in and they have committed to what the 196 nations committed. The goal is to limit mean temperature rise below 2020 by 2030, I think, right? Yeah, 2030. It's a big goal. Even 2 degrees difference makes a big thing. Even to do that, many countries protested. We don't have that kind of money. Even India said the same thing. No? Only people like China and people who are burning a lot of coal, they have to put up a lot of money and they don't want to do it either. So there is a big issue about how we go about. But India played a good role. India played because every day, other day, when we see the Delhi pollution and the people getting asthma, the health problems, our government did not have any other option other than attacking this problem locally, at least for us. And I think the government has done enormously good job since that. And the progression, what is going on, what I observe from here is enormously progressive, very nice. I think it's not easy, but as we go, we are moving forward. So India simply pledged that in agreement that we will reduce the fossil fuel use with alternate fuels and reduce greenhouse gases by 40% by 2030. And the last year's meeting, the Prime Minister said, we need a little more time, but we will achieve much better goal than 40% by 2070. and some people objected to that anyway. That's a different issue. We are doing good. We are doing it, but the push is from the next generation. They have to push it hard. They have to educate the elders. They have to make the policy makers, the older generation, to grow up on this subject. It is the younger people, like what the PhD students, the master's degree students, the environmentalists. Those are the people who have to give it innovation, and they have to push this up. This is an important issue, and I really feel more than people like me, of course I'm done anyway, even people with the middle age in 50s and 60s, the younger generation have the intellectual capacity, their vision, they're passionate. These are the people that we have to believe and trust and depend on for the future, for in this particular issue. And India is ready for that at the moment, it's in my opinion. Next slide, please. So let's see what's happening today in India. As of 2019, according to ONGC, which is called Oil and Natural Gas Corporation, the only corporation that is involved in this field, I mean, in extensively with investment, we consume about 5.5 million barrels a day of oil and other petroleum products, including the other petroleum products, the other things that we, hydrocarbons, some of the hydrocarbons. But our production in 2019 was only 1 million barrels a day, and we are importing 4.4 million barrels a day from outside. So I'm not sure people understand it. Probably this kind of import is coming from, how are they transporting it? I don't know. Maybe they're transporting with a lot of oil barges that come to the ports and then pipelined into the country somehow. There is a pipeline infrastructure for very small infrastructure for oil flow. And I have no idea how to do it. I mean, what is happening with that? But these are the numbers I got from ONGC. Then I said, oh my gosh, 4.4 billion barrels a day. You know what? Next slide, please. Yeah, these are the barrels we talk about. It's a 45-gallon barrels. Each one weighs enormous, and millions of tons of this oil is coming into the country. Go back to the slide again. That's oil itself. That oil is used in refineries, and the refineries produce various other products. The plastics and things like that also produce ammonia, methane, all those things they produce the refineries. But that is one of the sources of our current 2019 source of pollution. And this is how the amount of quantities that we're using. When it comes to natural gas, currently our consumption in 2019 was 2,100 billion cubic feet, and that is equivalent to some 50,000 tons. Each billion is about 50,000 tons of natural gas. It's a huge one, huge quantities. But that's our consumption, and we're producing about 1,000 billion cubic feet in the West Coast and the Godavari Basin, things like that. There's a lot of being done. We still import 1,100 billion cubic feet of the natural gas into atmosphere. It's large quantities. You can never get this gas in a gas form. If you want to have a gas form, it's unimaginable to think about the volume we require, even if you pressurize to 200 bar or 230 bar pressure. I mean, so it has to be produced, bring in a liquefied fashion. And our liquefaction processes in India are very minuscule. We don't have that kind of infrastructure. So we have to, next slide, please. We have to import this kind of thing in India, and then next slide, please. The following. Then we're looking at in 2019. No, the first. Go back a little bit. Now we talked about 2019 quantities, and India is proposing to bring additional. All of these things have to be produced, bring in only as a liquid natural gas, LNG. Okay, LNG, which is liquid natural gas, which is transported in a very cryogenic tanks, which is very low temperature, low pressure gas tanks. And then now we were talking about the volume of that one, 2.5 billion cubic feet per day of LNG. Huge. Imagine, that's what we're talking about in 2023. I want to caution one thing though. Don't take literally the numbers that I'm mentioning. Okay, these are all they were taken from different reports, and I'm not sure if I can authenticate every number that I'm talking to you about. But all I want you to take is the quantities, the magnitude, order of magnitude of quantities of the energy resources that we are looking for the demand and supply. Okay, don't worry about it. Whether it is 4 billion, 2.3 billion, doesn't matter. But look at the quantities that you talk about. How can we bring in that kind of LNG from outside imports? This is the only way to do that when is huge tankers, which is a tremendously big business in the world. Next slide, please. There is a tanker. Okay, believe it or not, these tankers are about 3 or 4 times longer than the football field that you play. Okay, and these carry liquid natural gas from Qatar and then Indonesia and some other countries that in America, which they get the gas out of the earth in locally, scrub it, make it, then they liquefy it, and then put this in kind of tanks and transport to various. They export that one to countries like India, and we are also getting something from USA and mostly from Qatar and Indonesia. These tanks contain about the biggest tank today we know is about close to 90,000 million tons of natural gas in there. So millions of tons of natural gas. Don't worry about the number. I don't have the access to that now. Huge quantities have to be brought in. And this kind of tank, one tanker will have, a huge tank will have about 5 days supply of energy to natural gas energy that we need in India. Okay, in the total India. That's a huge one. That's a mind-boggling type of industry that's going on. And there are companies in India who are trying to build this kind of tankers. I think there was one in Kochi in Kerala. And the number of companies that are into this business quite deeply into it for transporting liquid natural gas into India. But if it comes in, India has got some time ago, I think if I remember about maybe 10 years ago, even after that, I guess maybe five years or so, they said, if we have to import this kind of natural gas, we need to receive it somehow. So they did. Like, next slide, please. Then they said, we will have LNG terminals all over the coastal area. These are the terminals that we're looking at. Some of them are already built, like one in Kochi Petroleum. I think GAIL has got in Kakinada. Ennore is also something like that. So we have this kind of, all these dots are LNG terminals receiving large quantities. I'm not going to use numbers anymore. Unbelievably large quantities of liquid natural gas. Unbelievably large quantities. And then it comes to the coastal area from the sea, and they have to store it right away because you can't keep the tanker forever. So next slide, please. Then they have to build large number of storage tanks like this. Some of them are 30,000 gallons of product that they can store at cryogenic temperatures, so minus 160 degrees centigrade. Okay, because then the ship will go away, then they'll bring some more. Then we have to distribute this gas, this kind of product, natural gas, to the interior, to the end user. Now the interior end use is little less because it is used only for energy, electricity supply, and from the chemical industry, that's about it. But if you want to use it if you want to increase the number of natural gas vehicles, and you have to supply natural gas to them instead of gasoline or petrol or diesel, Then you need a transportation from here to the interior. Next slide, please. Here we go. We got to do that. See, from the tanker to the storage to, how do we do? In large quantities, you have to have rail cars. You have to have cargo tanks like this, which is going on the road, which can go around the small cities in Chennai and supply to a fuel station. Maybe this is an 8,000 gallon tank, but you can talk about number of 4,000, 6,000 gallon tanks that go into small areas to supply natural gas. And conventionally today, we don't have this technology, but these are all high pressure gas tanks, about 250 bar pressure. There's huge cylinders, and those are the cylinders that carry not that much gas like liquid, but quite small amount of gas, but they're all being used now in various countries. And this is called, instead of sending the natural gas by pipeline, because pipelines are not there in India everywhere, so they could use this kind of distribution to the end user, which could be a gas station, which will be a petroleum filling station, natural gas filling station. These are the transportation issues that we have. That understand that Adani Group was sanctioned to build 5,000 or more refueling stations in just Chennai. Okay, and in New Delhi is already there in a big scale. Ahmedabad, I think Bombay also uses natural gas quite extensively. But imagine the future when you are increasing the more and more automobiles on the road because the roads are getting better. Okay, more people want more automobiles. Then we have to have this infrastructure getting imported natural gas to the port, then from the port to the interior to the end user. This is a big transportation infrastructure that one has to think and plan, and correspondingly the auxiliary industry must also grow along with the import solution and building all the terminals along the coastal areas like I showed you. This is the transportation issue that must be addressed in a big scale, not a small scale, because up to the point that you come to the port, and the safety issues are all maritime issues. Those are all done long time ago. Okay, in fact, not a complete, the maritime issues. But once you store it in on shore, then the safety issue becomes a little bigger. And once you bring that one to the society with the big crowded cities, the safety regulations have to be very much more careful. It has to be a comprehensive safety regulation. Look at a picture like this and see what happens to this kind of infrastructure if you want to use natural gas or even hydrogen as an alternate solution to the oil by itself. Okay, the petrol and diesel by itself is a huge issue for the country. I'm sure, I think I come across a number of reports and policy statements, policy reports on this one. I can't get into detail because I don't know much about the Indian way of how the progress occurs every day, or who is doing what. But I'm looking at from here into India rather than being in India. So my knowledge is very limited to say anything about what is happening, what should be happening in India. Okay, that's one thing. Next slide, please. Next slide. So that is what I'm talking about. You're going to bring that kind of, this is not our country anyway. I just brought this slide because we have the buses up there. We are doing already in Bombay and New Delhi. All the city buses are many cities are running city buses with natural gas. But you need to have that kind of infrastructure as they grow into this population. You need a natural gas infrastructure, supply chain infrastructure with the safety guards by regulations. Next slide, please. Now, of course, this technology has been there for many years, for probably 1980s and all. I was a part of this. The the growth of this technology, as a government official, I was involved in it. I was instrumental to develop the type of cylinder that you see inside the tank, and also the quality of natural gas that should be put into this, the corresponding materials requirements, and all those things. And this is what is happening here. The two cylinders are put in the cylinder with a 250 bar pressure natural gas, and that is used to run through a converter the engine instead of petrol or diesel. Okay, and of course, next slide, please. You can do that for the cars and other things. And many buses in here, they run with the kind of cylinders on the top of it. But in India, of course, because of our bridges, I think Ashok Leyland is always building natural gas vehicles with the cylinders at underneath the seats in the floor level. And that's a nice thing to do. But there's a lot of safety issues, I think. I don't know if they're talking about it, except that there are regulations to make these cylinders up to that, okay? And then beyond that, assembling them to running them, I'm not sure the Pune organization, somebody is looking into that. I have no idea what's happening. I can talk only up to the cylinder level, if at all, okay? Because I was part of the US government development of the standards and regulations for this. Next slide, please. So we need to talk about renewable energy. So it is not simply importing and all, whatever it is. Is there a free energy that we can get renewable every day after day? And that is we have a solar and wind power. And of course, we have been using hydropower for a long time. And I think with the river systems changing in India, there will be an opportunity to increase the hydropower by at least another 20-30%. I understand that from people. Okay, hydropower is also, because once we have the river systems, this was what ancient history. They want Ganges and Kaveri connecting in those days, long time ago, 1960s and 70s. I'm not sure if that is all done. Then we have a river systems flowing differently. The hydropower can increase. We already have enormous solar power. Solar power in gigawatts power is being installed and be already in there in terms of individual homes and buildings for the heating water mostly. Okay, then they can also heat power. But this is directly taking solar power to the heat. Okay, and that heat is not sufficient to make it steam and then get the turbines run. But so we need another technology in between, is a fuel cell technology, where we take the solar power and then use that one through electrolyzer to produce hydrogen. And now hydrogen will be used to run fuel cell, and fuel cell will produce electricity. Okay, that is a technology that India will have to harp on it in a big way to add on to, or ultimately replace even the natural gas to as an energy source, maybe 50 years from now, 75 years from now. The technology is somewhat matured in the world. There's a lot of companies that are trying to do with the solar, both hydrogen production by electrolyzer and the fuel cell technology, and that is creeping into the Indian economy, and that's wonderful news. But it will take some time, but it is doing I think the government is pushing it very hard on this issue. And of course, natural gas is the methane, which we talked about all this few minutes. It is abundantly available even on Indian shores. We have it, but it is it's less exhaust. You can use it as a bridge. Maybe for next 2 generations, we could use still natural gas, provided we control the effluent pollution things like nitrous oxide and particulate matter, somehow generate, innovate a solution to make it cleaner than it is today. And as it goes to cleaner and cleaner natural gas, we can also continue to use for a long time to come. So India will have a solution to replacing the oil for some time to come. That is an important issue that one should think about. How do we get this natural gas that we have? If you are importing LNG, okay, expensive. Naturally, it is clean. So we already have a clean fuel. So the question is, if you are producing in India from the wells, we got to think about cleaning it up much more than what we have. Even 1,100 cubic feet, billion cubic feet is a lot of natural gas that can go into society, right? So that's what I'm trying to say is what the energy policy has to be looking into these issues in a broader sense and start implementing the programs. And uh, again, hydrogen is essentially a zero emission, which I said how we can produce it. It will be done. It's being done now. Maybe it will take some more time. Worldwide, not just India. India is catching up. India is also, I think, if not in par, but potentially in par with the world in terms of getting the hydrogen production. And the issue is transportation. Hydrogen, to transport it, you need much higher pressures than natural gas, 700 bar, 1000 bars, things like that. So in parallel with the components, the containers that can hold hydrogen at high pressure and corresponding regulations have to go hand in hand. And that is being an important issue for India to be an indigenous product for a long time to come. Next slide, please. This is typically how it happens. The onboard is hydrogen tanks are filled with high pressure hydrogen, and there's a fuel cell there, and the hydrogen is taken into a fuel cell, and that makes electricity, and the electricity comes forward to the engine, and then the engine is running. Oh, I could use this, right? Yeah. This is a fuel cell system here, and then electricity is taken up, and the electric motors run the car instead of gasoline engine, internal combustion engine. So this is the model for the zero emission automobiles. So I'm looking at India as a bridge gap for the next 25-50 years. A cleaner natural gas and hydrogen in combination should be used to reduce the oil consumption. And that will impact the pollution, and that will impact the Indian health system. That will also be possible to reach the set goals to reduce the greenhouse gases worldwide. We are a participant into that one. And this is a technology that we got to think about very high pressure storage tanks and then solar power fuel cells for the car. And so the same technology can be increased in size, scaled up for larger power plants that you can produce hydrogen. Currently, somebody, I don't know which group, they are investing in 70 million crores or what, I don't know what it is, rupees for setting up solar power to get multi-gigawatt powers, okay? But future generation, for those innovators and those who are into the designing airplanes and stuff like that. Next slide, please. I'm an aeronautical engineer, so my passion is here. Now, if you have that kind of system applicable to mid-size airplanes, like flying from, say, Chennai to Bangalore or Hyderabad or some smaller planes, not a very big, at the moment, for the time being, within 10 to 15 years, we can use this solar system to produce hydrogen and use a fuel cell power systems to run airplanes. And you can reduce the pollution because of the airplanes running. But again, the European company, they were talking about converting the system to a huge 400 passenger airplanes, like that's Boeing 707, 747, whatever it is. But I think India should look into shorter harping fuel cell vehicles, and that will reduce the pollution quite a bit. Next slide, please. Almost done. So here is the LNG supply chain, which is where this is the punchline I'm talking about. All this thing I gave you the background and some kind of understanding of the infrastructure needs for transporting alternate fuels. Here is what I should say. Tankers carrying LNG have capacity of 90,000 metric tons. and a 5-day supply in India. So you need a lot of help. Ports will have a large cryogenic storage tanks. All of these things remain. Why I'm making every statement is impacting the next slide. LNG is loaded onto LNG cargo tanks to the end user. LNG is vaporized and compressed to about 250 bar pressure. Okay, this is what I said already. Let's summarize it. Why? Next slide, please. Methane emissions. Natural gas is, I told you, natural gas is cleaner to use for some time to come. But I did not say it is clean only after when compared to the tailpipe gas of a diesel car and natural gas vehicle. After you burn it, the exhaust gas is cleaner. But natural gas before burning it as a chemical is 80 times more potent damaging to this Earth atmosphere than carbon dioxide. So methane emissions has become a huge issue worldwide. USA has started regulations for that now. I think there is an announcement recently about a few months ago. Methane emissions is what my topic today must be from the beginning, but I brought this to the end to give you where is methane emissions occurring. Because these are all cryogenic tanks are all at minus 163 degrees centigrade. They have to be at low pressure. But they're all insulated, double walled, insulated, mylar, all the stuff. But what happens is when the heat is leaked into it, in spite of insulation, the inside gas will become, inside liquid, part of it will become vapor. But every liter of natural gas in liquid form will become 600 liters of gas at high pressure, at atmospheric pressure, 600 times volume you need. Okay, but because it is a closed one, the tank inside pressure will increase. But tank is designed for very low pressure. This boil of gas should not increase the pressure, so it will fail. So what they do now is they simply, whenever this vapor formed and the pressure goes to a certain level, they simply put up they release a valve and goes into the atmosphere. That is a boil of gas. That's called, you are emitting the boil of gas as a methane emissions. This is a big issue. Now we go back and visualize, where is it coming from? The tankers, huge tankers at the port, the storage tanks at the port, at the shore, and the cargo tanks and rail cars, that cryogenic rail cars that are going across the city highways and railroads. So the entire system has got a methane emissions problem. The system is going to create a methane emissions problem. Is it a problem? Today we don't know because we don't have that kind of cryogenic transportation system. But if you want to supply to tens and thousands of stations, you have to use cryogenic to get the mass transportation, right? Mass product transportation. That's it. So I don't want to go into detail, but a typical 100,000 metric ton tanker will have 1,500 kilograms of. So it is. Again, numbers, take it with a pinch of salt. They're very close, but pinch of salt. But if imagine maybe 50 cargo tanks filled with natural gas supplying to the fueling stations in the city, releasing all this boil of gas into atmosphere just in the city, you would have a hovering cloud of methane. That is a health problem. That is a problem. Sometimes they say it is 80 times more than, according to the IPCC, 80 times more potent than carbon dioxide. There's the other caveats for that, but it is potent. So we got to think about this issue. How do we solve the boil of gas, managing the boil of gas? The way we are planning for future to use natural gas as an alternate fuel to oil. This is an important issue that one should consider. Next slide, please. Next slide. So again, again, this kind of boil off gas issue would be, the first line would be the way what we are doing it. You take it in storage, then you can vaporize it, store it as a gas, and then put that high pressure gas into the tube trailers like that, and take it to the end user, which I think for timing, let us say it is a natural gas fueling station, CNG fueling station. The alternate way to do that one is now, because the more and more gas we need, you do the same thing from the ship, but put in the form of LNG in a cryogenic tank, which will be the cause of methane emissions, into, and then bring it to the local distributor or retail end user, vaporize it, and put it in the car and van and send it back. But there may be a solution that we can take natural gas as is, a cold in a cold form, and be able to supply it to, so that we can control the, you can tap the boil off gas and control the emissions. This could be a solution. So I just brought in what I did. This was in a peripheral way, the infrastructure, transport infrastructure of the natural gas, which is what we are in India trying to push, which is correct, okay? And we need that. We have to do it to replace at least part of the oil imports and use of oil in the country. And these are the infrastructure, transport infrastructure issues that I hope I brought to you. Okay, next slide, please. You see, what we have is, these are all the cryogenic liquids like helium, hydrogen, nitrogen. They're all the things that go into cryogenic tanks. But the last three are those one which are connected to greenhouse gas emissions. And that's what we were talking about it today. This slide is simply a technical slide, but not very important for the bigger issue, okay, that I described. So this is how we are. We can do something. This is how the problems are there, if they're all. But the bottom line of this one is, one has to comprehend the magnitude of the problem that we are talking. People will get a lot of headlines in the newspapers and say government is doing that and that. But after that, if you take that layer away, I'm trying to expose to you the magnitude of the problem. Now from this, next slide, please. So if you look at it, I'm just addressed only as transport issue, small issue of that. But you have big issue. There's so many issues about methane emissions in this one, right? So if you look at this one, the important thing is transportation is now low hanging. If not a fruit, it's a problem. We got to address it right away, right? Then what we have to do is, not that we still have, when you produce a methane or a natural gas, biogas or something, the agricultural people will come in. The forestry people will think about what is happening to the forest. Why are they firing? Is there any relationship between methane emissions and the forest fires? So many issues can be taken up, one after small ones. Some of them are big ones. But this is an opportunity for the people to think about contributing towards environmental effects, that betterment of environment. I hope I brought something out of this. It will be a little bit haphazard because the issues are complicated. You can't take one issue alone now. To bring it from where it is, what kind of world problem it was. It is now everybody is considering. India is part of it. India is significantly part of it. And all these youngsters will have, I think, will have tremendous outlet for innovation, thinking. Maybe you think about, you don't have to innovate a product or a system or something. You can innovate a policy to express to the elders to go to the government. Okay, you can innovate a policy. Policy is not simply something that only the elders, the people in the government and all should do it. Policy, you can make it. You can make it and pass it on to the government. That is innovation by itself. And we have this. I hope my talk will be effective in that way also. And I think I took a long time. Sorry, 1 hour, 45 minutes is what I thought. I'm sorry, I was kind of carried away to talk to you a little more than I thought I will. If anything that questions, I'll be glad to answer. But again, Professor Subramanian, thank you very much for letting me do that. I don't know how many people are tuned in, but it'll be nice. I hope this will give some kind of ideas to people. Like Dr. Suryanarayana should also think big on this issue.
Absolutely, sir. I mean, this is fantastic. I mean, first of all, this is topical for many reasons, sir. I mean, I should also give it first. Well, thank you indeed so much because this is a fantastic lecture. So, let me also tell you something, sir. I mean, I mean, this is something that resonates really, really well. Yes. So the Young Advantage program, right? The YAP was not meant for India this year. It was meant for China. And I actually showcased one of the slides that you presented, which is the Paris Accord. And the argument that you actually put forward, where the youngsters are needed. I mean, they are the primary drivers now, looking into the next 15 years. And that was the one that convinced. In fact, I was just talking about this to Professor Suryanarayanan last time when I actually invited him and convinced him that he should come and talk to us. This is important. This is a principal driver, and you clearly touched on that. I mean, this is important. Otherwise, they were not permitting me to take this because it's been running well here in the US. Why should we take it to India? That was a question. It was really hard for me to convince them. But that slide that you made a mention of, which is the Paris Accord, where you have more youngsters now in India, between the age group of 18 and 24, many trying to get into the field of environment, ecology, conservation, and things like that. This is important, and that slide actually convinced them when I actually put it across, and I had to buy some time to do it. That's fantastic. That's one. Number two, also is that you were talking about the ports in Western Ghats. Of course, there was a slide that you showcased a number of ports across India, and in Western Ghats, and I think west of India, you have about 6 or 7 ports. Starting from Gujarat, coming down. Bombay port is one, of course. Cochin is one. You come down south, and I think Ennur, of course, in Madras, but there's one
side,
exactly.
That area.
Yeah, I mean, one of the things that I argued about, of course, which I failed, was to try and convince people that we should not have these ports at all in this area, because I mean, Western Ghats is one of the key biodiversity hotspots in the world. You have so much of endemism going on, and these ports will definitely have a clear negative impact. And I think there's a clear hit on that. When you just bring the issue of transportation and linking that issue with the ports that we have in that area. I mean, there's a number of points that resonate, and I'll keep quiet because if you let me talk, this is so, I'm so passionate about this that I'll end up talking for the next 2 hours. So just keep quiet, and then we'll probably attract some questions from my friends and participants here. So, people, any questions for Professor Vinjamuri? People, please. Hello?
Somebody's there.
Yes, Shrishti, you want to go first, please?
Yes. Thank you so much, sir. The lecture was amazing. So my question was about the fuel system that you were talking about with onboarding hydrogen and using the hydrogen fuels. So it's definitely very beneficial, as we know, it's one of the cleanest fuels possible. But one of the problems with also hydrogen is that it's less efficient than normal vehicles or the electrical vehicles that we have. So looking at the current situation, is it possible if we can also look into biofuels, like, for example, ethanol-based petroleum, which is then, added to the petroleum, which also has the possibility to decrease emissions?
Yeah, you do have. Ethanol requires a lot of land crops to do that, okay? If you use the corn, whatever it is, and then we are taking away the food items for people to run in the car in a lazy way, okay, philosophically, right? Technologically, it is not also, because you can take it from me, just I make a statement. It is not a good way of to replace the oil. It's not efficient way of doing it. You still have to make ethanol, then you have to run the energy, that plants have to use the energy. Where is the energy coming from? Again, from natural gas, right? It's at the end, right? At the end. So you're only pushing the pollution towards the end. Same thing with the battery also. I'm not negative on electric vehicles. Okay, the electric vehicles will have storage capacity of the power that they want. But then here is a good information. People in the West, like USA and other people, their specification, their requirements is unbelievably high compared to India. Okay, they want to drive 400 miles not stopping. You can't even go 4 miles without stopping here. Right? So that's so that kind of you have to be very careful when you talk about the EV vehicle design for Indian environment. In which case it will work to some extent. Okay, it will work, but definitely it is not more efficient than hydrogen. Definitely, hydrogen. See, where if you go to EV vehicle, okay, you need power to charge it, right? So where do you get the power from? Either coal-powered, oil-powered energy, or possible that you can charge it also from the solar power. No problem, right? No problem. But then at the end of this, then the batteries have a short life. Battery technology has to evolve, which is, I'm not against it. I'm telling you about EV vehicles, but you want to be careful. Okay. So, but it's not required that you have to compare EV vehicles with hydrogen with efficiency and all, because the demand is so much. Both of them live side by side, right? You can also make infrastructure such a way that you can charge a vehicle or fill the gas in hydrogen. Right? You can do that. This is the innovation ideas that you guys are bringing. Okay, and your statement, I'm afraid if I can say, came out of some report. Somebody said that maybe Tesla people trying to push their vehicles into India, and then say, okay, hydrogen is bad. No, not at all. Hydrogen is much better solution in the long run. Long run means not next year or next 5 years. I'm talking about 25, 50 years. India is suitable for that. By that time, we would use, maybe we'll have a good source of water from the seashores to electrolyze it and get the power out of it, right? Today, water may be a big problem. If you, in a large scale, if you look at it today, but in 25 years, we may have water resources, solar resources, then we can get electrolyzed to hydrogen. By the time we'll have a safety regulations for the storage and transportation. Okay, so hydrogen is in fact more viable system than EV. But for the time being, at the moment, natural gas will dominate, provided we make it. Okay, if we use LNG imports, then we'll have a cleaner natural gas, not a problem. But if you want to produce and scrub it and do it in indigenous sources, then we have to have cleaner than what they have today. Today's natural gas has got, in India, as I understand, is higher dew point, much more water in it, and you don't want water in the fuel there. Again, this is too much detail I'm giving you. Your answer is yes. EV vehicles should be redesigned for Indian road conditions, Indian travel conditions, and hydrogen should be developed right away to make it zero emission vehicles, and ultimately, okay, from source to wheel to well, that is, or well to wheel, that as I say, and both of them can live together for the long time to come. But intermediately, natural gas also should be a part of it. It will be for a shorter period of time, next 25 years, natural gas may be a major part of the combination. These three. That's my view.
So yeah, thank you. So we have a lot of questions. So I think we'll go one after the other. So otherwise, it's going to just eat up.
Okay, I'll make it short.
Professor Suryanarayanan, sir, it looks like you had a question. So please.
Yeah. So first of all, my sincere thanks to Vinjamuri for a very thought-provoking lecture. Now we are definitely facing this crisis all over the world, and there are thoughts of bringing this concentration of these gases down. So they're trying many things, like, as you know, they're trying to change the bacteria within the intestine of the cow so that they release less methane. And so ultimately, what makes me think is to slightly move away from regular science and go into some sort of a philosophy. Human being as a species has done, it's extremely selfish, isn't it? So a time has come when we cannot have a scientific solution for every problem that we create. We can manage, but for how long? This, emission of these gases and the change in the atmosphere, the climate change is one good example for this. So I think there's a thing called deep ecology, which says that you can browse and you can find out, which says that we should, the human species should respect the environment and then not treat it as something from which we just take away and don't give back anything, because a time has come, because the population has increased so much, as we all know, and the demands are so high. So what is one good way, apart from scientific way of managing this issue? I think right now the most important thing would be to adopt what is known as minimalism, right? So we know that there are families having 2 cars or 3 cars, and I saw in this. I remember seeing this photograph in Ohio Botanic Gardens where they have shown a photo of how much a family of 4, 2 parents and a teenage boy and a teenage girl, how much they need as food for a week. They're taking a photograph of that. I'm not finding fault, but I was surprised to see that the Americans, the food, the picture that showed them all food that the Americans would require for a week for 4 people was enough, would be enough for India, for an Indian family of 4 people, for maybe a couple of months. I'm not joking. Wastage should be avoided. I have witnessed this in the US the very first day when I went there. What surprised me was the use of this tissue, paper tissue, to wipe your mouth or your nose. I will just take one piece of paper like that and then throw it. That tissue could be used for, you could use, why don't you use a handkerchief that you have been using? So in my lab, people are using gloves like that, rubber gloves, plastic gloves. You just take a pipette, do some work, throw the gloves, take another. So my collaborator, who was earlier our student, Venkat Gopalan, he has that a typical, I would say, he still has the typical Indian way of thinking. So he said, we should not waste this. We should. So if that is one major way by which we can at least manage and then bring down, or at least keep this gas levels at least to a constant without any major increase in the climate, in the increase in the temperature, global temperature, till something really, achievable is discovered, which I doubt very much. But then for this, we need global cooperation, which is lacking. And I don't see in any way such a cooperation can be achieved. Carbon footprints, like the developed countries can always say that, no, we have enough. We have been polluting the earth, let us stop that. What about developing countries? They would say, you have enjoyed everything, why don't you enjoy? Why don't we enjoy? So it's going to be really tough. And as Dr. Vinjamuri and Dr. Srinath mentioned, it is in the hands of youngsters. So we should think in these lines, especially a deep ecology approach is really needed. When you can think of changing the bacteria inside the stomach of a cow so that so that I could lead a pleasant life. And why don't we change our habit? Why don't we use there are methods and things of each individual using a car? Always use public transport and things like that. So why don't we try to reduce our dependence on these things? If everyone does throughout the world, almost all people are using such energy. So if everyone can reduce a bit of this, there will be an enormous reduction, at least for some time. Till the youngsters, you give the youngsters a chance to live in a better world. That's my opinion. So thank you again for the really interesting lecture.
My comment to you is that yes, there was two ways of looking at. I think when we were very young, okay, we were told a story that somebody had 3 children, and then the father said he has got a bundle of wood tied together, okay, and then he said whoever is going to break that one will have my property.
Yeah.
Okay, one fellow went to get some kind of help and all. The other fellow tried to break it, and the third fellow removed it one by one and then broke it. Right. Yeah. So, if harping on your philosophy, it is easier to tackle our problem locally by ourselves.
Yes.
Okay, first, let the way you're right. Globally, you must think. Let each country think for themselves to start with, and except for the fact that those who cannot think and who cannot afford, we would give a hand to them to think and do the help. Okay, each country should do that. Okay, each country, if it's better than the next country, then they should be able to do that. If we are better than the next country, we should be able to do that. If USA should be able to do that. So this is how the cooperation of the government comes in, but each country has to think for themselves. Today, that's why I brought in the Indian situation. There was some criticism, your criticism was there buried into my statements. Like, why are we building all these things? Why are we making people lazy? Okay. Why are we importing all this nonsense into the country, like foreign cars and Mercedes-Benz and all those things? Why are we harping on the human weakness of the desire to do something that is not really necessary? Philosophically, you know that our philosophy is that, right?
Yeah.
So again, as I told you when you talk, this kind of discussion should propagate at the philosophical level, not technical level. Okay, propagate somehow to the society through the media or the lectures. Encourage younger people to tell the other students said philosophically, we could have elders can help them develop lecture notes to tell 50 of the students in a class in a seminar. You and I don't have to be. I don't have to do this. Okay, I mean that those people can do it, provided we can give them a hand to think philosophically, think like this. So this one student can propagate your philosophy to 50 students.
True.
Okay, even if you take 80-20 rule, 20 people will generate the requirement that you are asking for. So there are situations, but simply by saying that, I'm not criticizing you.
No.
Saying, but the global issue is what we should consider, we cannot consider. Yes. Like I told you, okay, the magnitude of one country, one shipment itself is so high. So you got to visualize that way. So I am encouraging younger students to think even philosophically, like I said, and try to make a statement of what we should think about, why we should waste something. Okay, what is necessary to go to someplace in a hurry if we don't have to?
Yeah.
Things like that. I'm sorry, I will stop here.
Yeah, no, absolutely, sir. I mean, can I just share my thoughts here, sir, if it is okay, with both Professor Suryanarayan and Professor Vinjamuri. I mean, this is, I don't know if you're able to see the screen.
Yeah.
Okay, yeah. So, I mean, Professor Suryanarayan was making mention of deep ecology. I mean, this is a second year MS lecture slide that I present, right? I mean, I completely resonate with what Professor Suryanarayan said, and also what Professor Vinjamuri said. We have a false understanding of the efforts that we put in, right? People wear leather shoes and then talk about really trivial things in the name of doing something really good. A glass of beer, right, 250 ml, utilizes 75 liters of water to make. A cup of coffee that you drink is 140 liters of water. This is the water footprint. A slice of bread is 40 liters. An apple that you eat is 70 liters of water to make. A hamburger, a t-shirt that you use, 2,000 liters of water. What are you going to do about it? Can you, I mean, people, these people, the so-called people who talk about, trying to do our bit, whatever, they just go and they end up in a frenzy buying spree. Why don't you use your t-shirt for 5-10 years? Because your t-shirt is using 2,000 liters of water. People talk about, why don't you not use your laptop for 2-3 months? I mean, that's productive, but they end up so much of money. This is a topical point that I raise when I talk about deep eco. I'm not an expert. I'm trying to learn things from Professor Suryanarayan and all the time. And a sheet of A4 paper, right? 10 liters of water. A pair of shoes. People use leather shoes. I'm trying to avoid consciously 8,000 liters of water. What are you going to do about all this? If you try to do something about all this, this is clearly, something that will resonate with deep eco. Sir, correct me if I'm wrong, sir, please. What Professor Suryanarayan and the microchip, 2 grams of microchip, 32 liters of water. So, do you want to just, use your cell phone for a longer period of time? Use your sheet of paper for a longer period of time rather than trying to advise people of what needs to be done. I mean, there was a suggestion that was made to me, which I clearly put down. They were saying, oh, can we all work from home now? Can we not go to the offices at all because you're saving so much of electricity, so much of energy, and it's all working now. You're teaching. Can you use your laptops? But what the point they're trying to miss is the human interaction and the importance of learning, the one-to-one peer learning that's clearly missing. The amount of impact that you would make by spending a little more electricity by actually being together, meeting with people and learning from professors is a lot more than trying to conserve the small amount of electricity, just working, online and being inside. So there was an opportunity that was given to me as a director, and I said, no, as soon as possible, we are heading back to the office. I don't mind. I mean, it's costing us $70,000 more. Clearly, there's no doubt about it. And I said, absolutely, we are going to do that. Electricity is more. There's no doubt about it. The amount of water that we use is more. But the overall benefit that we derive out of all that, the human interactions, being together, working together, the benefits of it far outweighs the cost environmentally that we put. I mean, this is clearly, what to say, something that resonates with what Professor Suryanarayan brought in, in terms of the ecological thinking that he was just talking about. I'll stop here. So does it make sense, sir? Is it?
Yeah, absolutely. And so I'll just take half a minute and then I will. So the usual question is that is asked is, it's easy to advise. Do you follow what you say? Yeah, right. It's very easy to advise. I don't know this. Do I follow what I say? So to impress on you, I'm not boasting. To impress on you, I've never had more than 4 shirts and pants in my life at any given time. And when a shirt is damaged or torn, it's only then I go on. So I try to tell this to my children, my 2 sons. I've not been very successful. And see here, this is what I do. This is when I use a paper, I also use the other side, the non-printed side for writing my whatever rough work and things like that. So these are simple things. It looks like it's a trivial thing. No, it's not. If everyone does it, then we could really, to an extent, manage. And but then we could always remember we are now at I believe that we are at crossroads. It's impossible to bring back the type of environment we had just say 30 years back. I don't know whether experts like Professor Vinjamuri should say this, should confirm. It's extremely difficult. And so the contribution by the youngsters is very important. Not only practicing this, but also to educate others. And we have a peculiar situation in India. Sorry to say this. Generally, experts in the fields are never consulted. Right from even TV interview to even policy making. I'm not blaming any government. This has been our. I would be more impressed if the cine actor whom I appreciate talks about nuclear fission than a scientist who is working in nuclear fission. This is the way we proceed. So we should.
That's why I said,
yeah.
If you remember that's what I told you about your lecture. It has to go back to non-bacteria people. Right?
No, when you mentioned linking of the two rivers,
Yeah.
as you mentioned, it was proposed the British.
Long time ago.
Yes, and had they done it at the time, they would have saved so much money. Even
Right.
the money that they are going to spend, it's amazing now. If you're so, these are the things that people, youngsters, should consider. And so, this lecture, I'm really happy and grateful to. And it's Srinath. Thank you again for. Let me tell you, I'm not for choosing the right person to influence young minds. Thank you.
Thank you so much.
Others, yeah.
And absolutely, no, thank you so much. Thanks. I mean, I'm always a student, sir. I've tried to learn all the time from you. Although unfortunately, I've had limited opportunities to interact and work with you. But I hope that changes, sir. Thank you so much. Yeah. And of course, Professor Vinjamuri, sir. I mean, whenever I try to meet with him, I try to spend at least 20 minutes, trying to learn or understand the research that he watched. And he recently opened a patent, a week ago.
Yeah, amazing. Yeah, but that puts me back into my. I was thinking that last week I turned 70, so I thought I'm too old to do any work. Now that he has got a patent, I will try for my patent. Okay.
Of course, sir. Of course.
I tell you what. I thought I was the oldest man ever to get a patent. There are two people who are 100 years old got patent.
Wow.
So I'm saying,
yeah, you also should continue. And then before I conclude, I have put up this hand. I don't know how to remove that hand from the thing. So actually, I've stopped.
Your hand and your impact will never go away, sir. So
no. So don't think that I'm going to ask any question. Please go ahead with others who have raised their hands.
Sir, we always need your hand, sir. So please let it keep going. No, absolutely. Thank you. Yeah. So we'll take one question from Rudra. Rudra, do you have a question, mate, please?
Thank you, sir. Thank you. Am I audible, everyone?
Yes, you're very, very audible. Yeah.
Thank you, sir. Thank you for such insightful presentation. Well, I had two questions. Like you talked about connecting Godavari with Ganga. So recently, NASA in a report said that the majority of coastal states are at high alarming risk of being submerged by the next 50 years. So connecting these, inland waterways will have further negative ecological implications. So what is your opinion regarding this?
I did not fully understand. Will you please repeat again? I'll try to understand.
So, sir, I was highlighting this NASA current report that said that India's major coastal states are at high risk of being submerged by the next 50 years. So like you presented this idea of connecting rivers through the Indian subcontinent. So will this further amplify this problem and can get further negative ecological implications?
Not at all. They're not at all connected. First thing is, the NASA report is saying because of the global warming, I can say El Nino effects and all, there appears to be that the sea level is rising. Okay, when the sea level is rising, then sea tend to, actually this is amazing phenomena. There's, you can see in the small creeks, if it's little rain, they flood. There's so much of water in the oceans, they never flood, right? They never come as a flooding, right? Unless something pushes from a earthquake underneath the water, something like that, okay? But what they're talking about is essentially the global warming, where the sea level will increase. If sea level increases, it will come down to this. So before India can go back, California will go down. We can watch at that time, okay? We will watch at that time. California is almost there. Okay, that's so NASA report, you ignore it for time being in this problem. Okay, but instead of going that route for a long time of somebody's instead, contribute to the immediate need of something, like what he said was, if you have a group of people that you can talk about a certain issue related to India and for India, okay, that would be much more beneficial. And so as a scientist, I would say this is not a concern at this time for me. This is not an urgent matter when the sea level goes up and the coastal will be submerged. Again, repeating your statement, interconnecting the two rivers has nothing to do with the seashore. Okay, they're not at all. Nothing is going to mess with the rivers. Are much better behaved. I mean, they're definitely different architecture for rivers than the oceans. Okay, so let go. From you, I'm blunt. Don't worry about that idea. Let go. Okay, I will tell you a joke and then let go. One fellow was worried about like you, that he said, "Oh my gosh, this is real thing." That one of the pravachanams that people, one of the people who were talking about some Upanishad or something. So the one fellow went to seashore and said, "My gosh, it's going to drown all this seashore." So he took this coconut chip, okay, the one with the empty one, okay. He tried to empty it. Then with that one, okay, you want to empty the ocean to reduce the water a little bit. The other fellow, much more foolish. He thought, "My gosh, it's going to empty." So he threw the item and threw it away. So those issues are all imaginary at the moment for us. Okay, I would completely ignore NASA report. What I never read it, but from what you thought, it is influencing you. Okay, and that should not influence you. That's not right. Don't worry about that. Do it immediately next time. Go back to your street and see if you can keep your street cleaner. If it's not cleaner, go and talk to the local municipality and tell them what to do. Okay, so many things we can do, like Dr. Suryanarayana was saying it. Okay, so many things that you can do to improve, first of all, your house, your street, your area. Okay, and then the nation. I'm talking about the nation at a different level. Okay, but I didn't talk about somebody else's report. I'm saying what was the current issue is. And I'll correct myself. My title should have been how to manage the greenhouse gases. I should say what the solution. The solutions are not there for a long time to come. Complete solution is difficult to say it is a solution, but it is how to manage it to that extent that you are reducing the greenhouse gases to a little amount by your action, right? That's what I'm trying to say. But yeah, I'm sorry I said this, but I'm very, not only to you, to other people also, don't worry about some scientific report. It should not cause you at this time of the in our national history. Okay, as national, what we have to do to the people, because we're sliding down the path of difficulties. You got to get out of it first before you think about something else, right? So that's my advice. I'm sorry I did say that, but I have a right to do that because I'm so old.
Well, I don't think you're old, so you just got a US patent. That's fantastic. Very nice. Yeah. There are no further questions, people. Any?
So I have another one question.
Sure. Go
Yeah.
ahead. Yeah, real quick.
Sir, like any report we see, we always see China and US are the major carbon, they release major carbon. So, and they go away with paying such huge monetary compensation. So, is there any unbiased alternatives?
For her, for who?
For these superpowers, they are always on the top of high carbon emissions.
China is leaps and bounds advanced compared to America. Okay, not as compared to Europe is much better than America in terms of accepting, developing alternative fuels. Okay, which is hydrogen, and they're way up there. But then their dependence on coal is so big. In order to do anything to reduce that will take generations and generations. So there's no way you can say, is there a solution today, tomorrow, day after tomorrow, or next year, or next 50 years, maybe. Okay. So the lifestyle, you got to project your vision to the society, because the time constant for any society is one generation, if not more than that. That is, one generation is 25 years. Okay, so do not think about it. But today we are managing it. Okay, they're also managing it. They're managing how? They're investing enormous amount of money in the hydrogen fuel cells. Much. In USA, we have about 4,000 fuel cell vehicles. In China, they already have 1 million vehicles.
Oh.
So they're doing it. Okay, we don't have to think about, we don't even advise them. We are in fact do what we have to do, how best we can do in the country, how best we can harness the solar power, the wind power. Okay, is there something that we can do to reduce pollution around our houses, around the street and all? These are the Suryanarayan well put that one. It's philosophical. It's not even philosophical. It is a necessary requirement for youngsters to think this way. Yeah. To help tell in America at one time, a lot of parents, fathers, they stopped smoking because the children told them to stop smoking.
Oh, good.
Right? It is children who influence them to not stop smoking. It is you, this your generation. Don't worry about issues that cannot impact us at the moment. Do slowly start someplace. That's why I showed you that one. You look at the chart. If you are an environmentalist, you have a place somewhere there to start working on it for India, in India.
So what are the chances of fusion coming in as a source of energy? How?
Oh yes, in fact, if you look at my publications, I worked on shock theta pinch, this thing. I worked on fusion. There's two research reports I wrote at the time. Oh. Yes, fusion power is a solution, definitely, but better than atomic power. Yeah. Okay, but the problem there is the cart before the horse. To create a fusion reactor is tremendously expensive. Mm-hmm. There's nobody to invest in that except for researchers. Okay, that's the thing. At Boston, I think my MIT has some solution to that, because when I worked in I published a paper in 74, that I was working on the project. At that time, we were looking at superconducting materials. Okay, it got 4.5 degrees Kelvin. You need to have a copper like, so I worked on that one. Then Boston came up, oh no, we can have a material that will become superconducting much higher temperature. That was about 30 years ago, maybe. Okay, I didn't follow till recently. Okay, in fact, that particular aspect of it, except that when I did the liquefaction of helium in those days, I found that why would I make helium liquid and then transport? Okay, at 60% efficiency, I can tap cold helium and transport.
Oh,
okay. That's what I was now looking at. Of course, I'm getting my efficiency has gone down. One of the problems with the fusion power reactor is the enormous amount of power you need to run it, and the system has to be very complicated to get this thing. And but I think in a smaller, in my opinion, compared to a small scale atomic power, an atomic plant, fusion power is more feasible.
And less polluting, perhaps.
Yeah, yeah.
Less polluting, perhaps.
Oh, absolutely. Because the power you get, only problem there is the temperatures. The handicap is the materials. The handicap is the instantaneous hike of temperatures goes into thousands of degrees centigrade, and we don't have a material to stand that even for a short period of time. The obstacle in fusion power is the high temperature materials, and ceramics have come up to some halfway, I think. I'm not sure. Okay, and when the technology can be done. Okay, let me say, I must go back. The technology, as I understood when I worked in 1970s, okay, not today. I don't know what's happening today. Okay, but it's possible. It is at a small scale. I think fusion power is better than atomic power in the labs. Even because the temperature, the temperatures are so high. If you can harness that, and that's all, it can heat the water like no matter. They run the turbines, right? Yeah. I'm sorry, I don't know that much about it, except that I did work on fusion power. I have a little bit background on it.
Thank you, sir.
Thank you, sir. Thank you so much, and thanks for the great question as well, sir. That's great. Soham, can you take your question probably right to Professor Vinjamuri, if you don't mind, because we are way ahead, about 20 minutes ahead of over our schedule, if you don't mind. So
just wanted to add that in India, the ITER project is there, which works on fusion. That's it. ITER, yeah.
What say? What did he say?
ITER. ITER project is there in India, which works on nuclear fusion, getting the energy from nuclear.
So Soham, my suggestion is, can you just write to him if you don't mind?
Yes.
Better. Okay.
Yeah. Fusion power maybe is kind of supplement. They're coming up to small scale, not fusion, the atomic power, not fusion power. Small scale power plants, okay, that may be gigawatts type, 100, 200, 300 gigawatts type. That may catch up fire in future for electricity. Yeah. Okay. That will be maybe what I know that may not be that far away. Maybe in 25, 50 years from now, we may have those kind of plants. Okay, then we can think about discarding hydrogen. We don't know. Life is going on like that. But for next 50 years, we have natural gas to go with. Hydrogen will come very, very fast. Okay. And then a lot of automobiles will run on those things. And maybe we can contribute to reducing the greenhouse gases. 50 years is a time period. Okay. That's the minimum time you should visualize it. Okay.
Thank you, sir. Thank you so much. Yeah, that's great. Fantastic, sir. Thank you. I think now what I would do is I just request my friend, I don't know who's going to do is it Sparsh? Are you doing it?
Yes, Srinath.
Yeah, please. Yeah, if you don't mind.
Yep.
Yes.
Yes, sir.
So I would like to extend my heartfelt gratitude to Professor Gopala Vinjamuri. Thank you very much for the fantastic lecture. And I'm sure everyone enjoyed it and learned a lot from you. And you are a true inspiration for all of us here. So the topic you talked about, greenhouse gases, it's something that is affecting all of us, and especially sharing the new information about the boil-off gas in transport of methane. That is something I wasn't aware of. And, the first step to solving any problem is to first think about it, to know about the problem. So thank you, Professor Gopala Vinjamuri, for introducing us to that.
I enjoyed it. I talked almost extemporaneous. I didn't prepare any talk in writing. Okay, I just talked as if it's a story that I visualize it, nothing else. So I may have missed a lot. I may have made a little bit of misstatements. But again, I warn you before I'll go, do not take the numbers as I told. Don't you overuse them. Okay, only take the quantitative aspects of what I said. Okay, so I don't want anybody to come back and say, where did you get this information? So take only quantitative magnitude, order of magnitude aspect of what numbers are used, okay?
Yes. Thank you very much. And I'm sure I personally asked myself this question after listening to you. I don't know about others. I'm sure some of them must have thought about it. That like, what's stopping us? What are our excuses? You know, at where you are in your life, and you've done so much work, and you've got so much more time to do some more work. So, you know, looking forward to that. So thank you very much. Next, I would like to thank Professor T.S. Suryanarayanan for his giving some thought-provoking comments. And I would also like to thank Dr. Srinath Subramaniam for making this meeting possible for us, you know, sharing at least this virtual space with Professor Gopala Vinjamuri today. And I would like to thank all of my fellow YAP participants, all the other participants of this lecture, from wherever you're tuning in, and any and all others who have proved to be instrumental in making this lecture today available to us today. And my name is Spursh Sharma. I am from Rajasthan. I'm currently pursuing my BSc in Chemistry, Environmental Science and Zoology from St. Joseph's College, Bangalore. Thank you once again, and have a great time.
Yeah.
Thank
One
you.
last statement. I'm always available. If you send me an email or something, I will answer, because I'm retired, and so I'll be glad to talk to any youngster, any idea. But I'll be blunt if I think something is not, I said that your thinking is not applicable today or whatever it is. Okay, but I'm available, and through Dr. Subramaniam. Okay, Professor Subramaniam.
No,
Okay.
absolutely. So, I mean, let me stop recording. I've got a couple of comments before you all leave. Okay.